Okay, today we're taking notes over groups and periods, which is terminology for the periodic table. So groups and periods tell us how to locate elements on the periodic table. Going up and down on the periodic table is called a group. Every group has a group number on top of it. We do not talk about these elements right here. These are transition metals. So group 3 through 12, we ignore completely. And then we have group 13, 14, 15, 16, 17, 18. I do want to point out the A number because that A number is going to be important to us, and I will explain more in a moment. Periods go left to right on the periodic table. Think of like a sentence ends with a period, a sentence is left to right. So the period number is over here. The only elements in period 1 are hydrogen and helium. And you have period 2, 3, 4. All right. So to set up my notes, I titled it, and then I have my periodic table down here, which is linked for you. If you are able to print it out, and tape or glue it on. If you are not, then draw it. It's just some boxes. You can draw it. So let's start with groups. Groups go up and down on the periodic table. The group number is written on top of the group. Need a different color. Let's use this one. All right. So groups are also called families. And this is because they have similar characteristics. Oh my gosh, I can barely fit that. Similar characteristics and reactivity. So sometimes you'll hear them called families. It's because elements in the same group going up and down, they have similar characteristics, similar reactivity. For example, we'll talk more about that tomorrow, but for example, group 18 or 8A, all of these elements are gases. They are known as the noble gas family. So every element in here is a gas and every element reacts the same. That's why they're sometimes called families. Now, there's another really cool thing. When we're talking about groups, the A number equals the number of valence electrons. Remember, valence electrons are the electrons on the outermost energy level. So I'm about to show y'all something so cool. This A number on the periodic table, so group 1 or 1A, is equal to the number of valence electrons for every element in that group. So cool. So every element in this group has 1 valence electron. You automatically know that. 2A, every element in that group has 2 valence electrons. Remember, we skip all of these. We're not worried about them. Every element in group 13 has 3 valence electrons because it's 3A. Don't get tricked on that one. It's not 13, it's 3A. So they have 3 valence electrons. 4, 5, 6, 7, 8. All right. Let's talk about periods real quick. Periods go left to right. And the period number is equal to the number of energy levels. Remember, energy levels are the rings in the electron cloud. They're where the electrons are located. So cool. This number is equal to the number of energy levels for every element in that period. So hydrogen and helium have one energy level. Lithium, beryllium, and across have two energy levels. So let's do a little example. Silicon is located in group blank period blank. So you need to be able to find an element when you're given the group and period, or tell the group and period for an element. This is kind of like using coordinates to locate something. So let's find silicon. Silicon is atomic number 14. So I can see that it is also in group 14, or 4A, but we're going to say 14, and it is in period 3. So you kind of have a up and down coordinate and a left to right coordinate, and you see where they match. So silicon is in group 14, period 3. So let's just practice for a moment. What is the location for oxygen? Let's see if I can get that glare. There you go. All right, oxygen is in group 16, period 2. Let's practice another way. What element is in group 2, period 3? So group 2, period 3, I go to where they meet. Don't get tricked. Let me show you how people get tricked. They say group 2, period 1, 2, 3. They say calcium, but that's in period 4. So make sure you really come over here on the left-hand side and go to 3 and find where they meet. Okay, you can be given the group number and the period number. This should be example number 1. Sorry, y'all. I think I need them. Okay, so example number 2. You can be given the group number and the period number, or you could be given the number of valence electrons and energy levels. So I'm going to say blank has, let's say, 7 VE for valence electron and 4 energy levels. So if you go on your periodic table, okay, I'm going to 7 valence electrons, so I'm looking at 7A. I know it levels. So I'm going to period 4, group 17. And I'm finding bromine. 4 energy levels tells me period 4. 7 valence electrons tells me group 17. Let's try another one. What element has 5 valence electrons and 2 energy levels? Okay, 5 valence electrons tells us what? It tells us group 15 or 5A. 2 energy levels tells us what? It tells us period 2. So 5A period 2 is nitrogen. All right, I just want to give you a little visual just to make this even more clear in case it's not 100% clear. All right, on our little periodic table, let's label a few things. Group 1 has 1 VE. Group 2 has 2 VE. we skip the transition metals. Group 13 has 3 VE. 14 has 4 VE. So you're dropping the 1 on here because you're looking at the A number. 5 VE, 6 VE, 7 VE, 8 VE, except there's one exception. If you look on your periodic table in group 18, the top element is helium. Helium's atomic number is 2. So it can only have 2 valence electrons. So that one's special. We'll talk about it more tomorrow. It has 2 VE, but every other element in group 18 has 8 VE. All right. Every element in period 1 has 1 energy level. Period 2 has 2 energy levels. Every element across in period 3 has 3 energy levels. I'm only going to draw one more because that's a lot of circles. Every element in period 4 has 4. Who does too many circles? 4 energy levels. I'm going to stop there. So in period 1, there's 1 energy level. Let's look at the difference between these two. Period 1, group 1 has how many valence electrons? 1. Period 1, group 18 would have 8, except for helium has 2. Let's do one more row. Every element in period 2 has 2 energy levels. I should have said let's do one more period. And I'm only drawing the valence electrons because we're not talking about all the electrons. So, period 2, group 1, how many valence electrons do we draw? 1. Period 1, group 2. 2. I said period 1. I'm sorry, y'all. Period 2, group 2. My bad. We're on period 2. Skip over. Period 3, group 13. 3. Period 2. Period 2, group 14. We need to draw 4. Period 2, group 15. We need to draw 5 valence electrons. Period 2, group 16. 6 valence electrons. Period 2, group 17. 7 valence electrons. Period 2, group 18. All 8 valence electrons. Okay, so you need to be able to locate elements given either of these two things, given their group number and their period number, or given valence electrons and energy levels. Think of it as like coordinates. You're going to group and period and finding where they line up.